Hey guys, Mr. Larson here. I just want to go over some factoring notes from 8.5. Here we go. All right, so there's a bunch of different types of factoring that we'll do today. A couple of them are familiar, a couple of them are new. So the first part of this notes will serve as a refresher, and then we'll dive into the fun stuff. At the basic level, we can factor out any common factors, and we look for common from the coefficients and constants, and then also from the variables. 3x plus 6. I can factor out a 3 from both of those, and I'm left with x plus 2. So just in general, at the basic level, remember, if you can distribute what you factor out and end up where you started from, that's a way to check your work. Okay, so always check that, especially as we get more and more complicated. That one might not be necessary, but it's good to just show the principle. Okay, so you'll try number 2. I'm going to kind of do every other one on these notes so that you guys have some practice. The key will have everything filled in. So if we look at number 3, this is really two terms, and it looks a little intimidating, but just like 3x was one term for the first one, x plus 1 times x minus 3 is all one term. Okay, x minus 3 times 2x plus 5, that's all one term. Now there's two factors in each of those terms, and we want to see if there's any common factors. So while it looks different, it's the same problem as number 1, just a little more complicated. So I have an x minus 3 as a factor in both of these. So what I want to do, just like I pulled out 3 with number 1, I want to pull out x minus 3 from both of these terms, right? So when I take x minus 3 out, those are now gone, and I'm left with x plus 1 from the first one, and how do I want to show this? Let me do this a little bit differently. Let's put a bracket. So I'm left with x plus 1 from the first one, this plus sign, and then 2x plus 5 on the second one. So the only thing different here, now let's clean up what's inside these brackets. So I'm going to get x minus 3, and then the brackets I don't really need once I simplify. X and 2x is 3x, 1 and 5 is 6. So this is almost all the way simplified. Just note that once you kind of clean up the brackets, you might have a common factor like I do with 3x plus 6. We'll notice that's actually the same problem as what I started with over on the first one. So I can pull out a 3 from that, and then I have x minus 3, x plus 2. Okay, so that's a fun one. Number 4, you guys can try. It's similar to the one that we just did. Okay. Okay, so this you guys have done before as well. If we look at number 5, anytime you have a leading coefficient of 1, so on your x squared term or whatever your first term is, that's like, we should like factoring those. This should be relatively simple for us. So these are going to look structurally with two sets of parentheses, and I have x and x. And then the numbers that go in these last two spots, I want to be able to add to my linear coefficient and multiply to the constant. So negative 45, I'm going to have one positive and one negative, right? So let's see, 45 and 1, 15 and 3, I think it'll be 9 and 5. So 9 times 5 is 45. I know I need negative 45. So the negative is going to go on one or the other. It would have to go on the 5, so that when I combine those, 9 and a negative 5 gives me a positive 4. So plus 9 minus 5. And remember, again, we're done with this, but to check it, this is how I get back to where I came from, right? I'm just going to distribute. So x times x is x squared, then I get negative 5x, then plus 9x, and then a minus 45. And this will combine to give me that positive 4x. Okay, so that's my check. I know that I had it right. Okay, so for 6 and 7, it's basically identical problems. One thing that we also want to see every time is a positive leading coefficient. So if you don't have a positive leading coefficient, it means let's factor out a negative 1. So then we're left with x squared plus 11x plus 28. Now I can factor what's inside the parentheses just like I did on number 5. So you guys can do that. And then again, for number 7, pay attention to any common factors that you can factor out so that the leading coefficient becomes 1. Okay, so I'll let you guys try 7 as well. Okay, 8, I don't know to what extent you guys did last year. So again, I want this to be a positive coefficient to start with, so let's factor out a negative 1 first. So I have 3x squared plus 22x plus 24. Okay, so this is when our leading coefficient is something greater than 1. Okay, after I factor out that negative 1, I'm left with 3x squared plus 22x plus 24. And I'm going to do a method called splitting the middle. You might have heard different names. You might have seen different methods. If you have something that works, by all means use it. But this one should work for you every time, and my students in the past have liked it once they realize how it works. So I'm just going to focus on what's inside the parentheses here. Okay, so you might start with what's in the parentheses. I just happen to have a negative 1 that I can factor out on this one. So first thing we want to do, let's take our leading coefficient and our constant and let's multiply those together. So 3 times 24 gets me 72. And what I want to do is find a pair of numbers that's going to multiply to give us 72 and add to be my linear coefficient of 22. Okay, so let's think of some pairs of numbers. Always think of the multiplication. There's fewer numbers that will multiply to your target than there are that will add to your target. So 72, let's see, 72 times 1, that's not going to add to 22. That's 36 times 2, 24 times 3. What's with 4? 72 divided by 4, that gives me 18 times 4. Okay, well 18 plus 4 gets me 22, so that's my combination right here, 18 and 4. So once I find those, I want to come back and I'm going to rewrite the trinomial that I'm trying to factor, but instead of writing that linear term, 22x, I'm going to split it. That's why we call it splitting the middle. I'm going to split it into plus 18x and plus 4x. Okay, so let's see what that looks like. Remember, I'm just focusing on inside the parentheses. So I have 3x squared plus 18x plus 4x plus 24. So I haven't changed the value, I've just changed what it looks like, right? 18x and 4x is still 22x. So now I want to group the first two terms together and the second two terms together. And then I want to factor out what they have in common. So the first set of parentheses, 3x squared plus 18x, I can factor out 3x from each of those, and I'm left with x plus 6. Now let's move to the second set of parentheses. So I have plus 4x plus 24. Well, I can factor out a positive 4, and I'm left with x plus 6. So at this point, notice, just like our previous examples when we were factoring out common factors, I have x plus 6 as a common factor. So let's pull that out front. So I have x plus 6, and then what's left from the other terms? I have 3x and plus 4. So this value inside the parentheses becomes x plus 6 times 3x plus 4. Don't forget, I also had this negative in front, so I'll just put a negative 1 or negative sign in the front there. Okay, I'm going to do one more of those because those are pretty tricky. So number 9, again, these are all even numbers, so I know I can factor out a 2, and I'm left with a trinomial, 2x squared minus 9x minus 18, that I can continue to factor, but it doesn't have a leading coefficient of 1. So I'm going to do this split the middle method. So again, I'm just focusing on inside. So I take my leading coefficient times my constant. That gives me negative 36. So I want to find a pair of numbers that will multiply to negative 36 and add to negative 9. So to multiply to be a negative, it's going to be 1 positive, 1 one negative. So let's see. 36 and 1 multiply to 36, but if I make one of those negative, it's not going to add to negative 9. 18 and 2, that's not going to work. What else? 12 and 3. Okay, I need one of them negative. If this one's negative, then those would add to negative 9. So that's good. So again, instead of this negative 9x, I'm going to change it to negative 12x plus 3x. Just changing what it looks like. So let's rewrite that trinomial. So 2x squared, I'll write it as a polynomial with 4 terms. Group the first 2 terms together. Group the second 2. Let's see, factor out what's in common here. So I have a 2x. I'm left with x minus 6. I can factor out a positive 3, and I'm left with x minus 6. Notice I have this x minus 6 I can factor out. So x minus 6. So those are gone, and I'm left with 2x plus 3. Don't forget I had this 2 out front, so let's bring that down. Okay, for number 10, you don't have to factor anything out first, so that should be a little bit easier. Okay, factoring, difference of squares. So to determine if something is a perfect square, check for the coefficient being a perfect square, and then your exponent having, or your variable having an even exponent. All even exponents represent perfect squares, okay? So 9x squared, the square root of that is 3x. That's a perfect square, okay? So this is going to factor 3x. So the first perfect square, the square root goes in the first spot. The second one, 4, of course, is a perfect square. Square root of that goes in the second spot, and you'll have 1 positive, 1 negative. Okay, feel free to distribute that out just so you can double check. Let me do 12 as well. So the square root of x to the 4th is x squared. Square root of 16 is 4, so plus 4 minus 4. And now keep in mind, sometimes when this happens, you're going to be left with another difference of squares, right? X squared and 4 are both perfect squares, so I can rewrite this as x squared plus 4, and then my yellow highlighted one becomes x plus 2 times x minus 2. All right, so guys, this program I'm using caps my recording at 15 minutes. I do that strategically so I can keep these videos short. Unfortunately, this one's going to go long. So I'm going to make a second video. It'll be shorter than this one, but this one's about 13 and a half. So log on to that second one, and we have 2 more types of factoring. One of them, which is pretty quick, and the other one that'll take a little bit. Okay, thanks, guys.